This lecture, we're going to talk about motion sensor. Before we actually talk about the sensor itself, let's actually review some basic physics, and because this is kind of the mechanism how this sensor works. Let's take a look at the electromagnetic spectrum. And I think most of you should be familiar with this already. So the spectrum is divided into multiple bands. You got radio, microwave, infrared, visible, ultraviolet, and X-ray, gamma ray. And this going this way from radio to gamma ray, the wavelength becomes smaller and smaller, shorter and shorter, while the frequency becomes higher and higher. So basically, there's this inverted relationship between wavelength and the frequency, because that equation of the speed of light equal to wavelength times frequency. And in our particular case, we're actually going to use the infrared. Infrared is basically the name means below red. So you see the visible spectrum, you have from red to violet. And beyond the violet, you got the ultraviolet, the UV, which is a high energy. Then the low energy is on the left-hand side. You got the infrared, which is below the red frequency. Now, the infrared is something that's actually that has an interesting property. What it is, any object that has a temperature above absolute zero, essentially any object that has a some kind of a temperature, it will emit a heat energy in the form of electromagnetic radiation at the infrared wavelength. So this is a very nice property. That's how the sensor is able to detect objects, because the objects emit the infrared wavelength. Now, the motion sensor, specific type of motion sensor we'll talk about is actually the passive infrared motion sensor. Passive infrared, passive means it does not generate energy, it only detects the energy from the environment. And the infrared is what we just talked about. It detects infrared to determine if there is a motion, a motion. There's an object that is moving around the sensor. So often this passive infrared is called PIR for short. And the PIR sensor measures the infrared light radiating from objects in its field of view. That also means we need a lens. We need to condense the infrared light from a particular field of view, a wide angle, to collect all this light into our sensor so we can detect the motion. And this particular lens that is used, it's called Fresnel lens. The Fresnel lens is actually the type of lens that's used in the lighthouses. So it's it uses sort of the idea of that is it uses more amount of material, and it will be able to actually detect the light, condense the light from wide angle into a focal point. And if we look at a schematic of this sensor, what actually looks like is this plastic here is actually made of plastic. It can be made of a more expensive materials, but it's unnecessary for our very inexpensive sensor. It's not very easy to see behind. I mean, you can actually, if you open this up, I don't recommend you do this to know it probably will damage your sensor. The other side of the lens looks like this, is rugged. And this is made so that the light will be focused onto the light detection elements right here. That's behind the lens. So this is the focal length from the surface of the lens to the element that absorbs the light, and this is the part that will actually generate a voltage difference. And then we have a signal coming out of the VIR. The input power comes from the VCC, and it also have a ground. So you'll see this sensor actually has 3 leads: the power, the signal out, and the ground. Just, it's able to detect the infrared light. That's kind of a, how do we detect the motion though? I mean, it sees the light. I mean, the objects around, if they're still, they all have light. There's many objects will emit the infrared light. However, the motion works this way. Imagine you have an object that's basically passing or moving from one location to another around this sensor. And the movement will actually cause the light getting condensed into the back of the sensor. Actually, the sensor, if you see the sensor like into 2 parts, logically divided that into 2 parts, essentially you will see that motion move from one side to another. And that's kind of how it detects that movement, because that movement causes the light goes into different parts of the element, the PIR sensor itself. And so that causes and that gets translated into electrical signal. And this signal starts from this sort of positive voltage to a negative voltage. And then if you look at the signal, that's actually output from the sensor is looking like this kind of a wave signal. Okay. And then the driver will basically measure that, voltage changes, and then determine if there's a motion in the field of view. And let's take a look at an example. We're going to wire this up into our PI. And there's 3 leads here, 3 pins. And we're going to connect this red is power, connect to 5 volts. So we're going to use 5 volts here. And then there's a ground. This connects to ground. This whole column is ground. And the signal out is this yellow line, yellow wire. And then here I'm using the port, so the GPIO pin 23. So you can use whatever number you need. And if you look at the physical sensor, it's kind of hard to make out because actually there's no wording which pin is which. So I'm going to give you this image here that will tell you which is which. And then you see there's 2 sort of a yellow plastic thing sticking out. This actually, one of them is for a just-in-time delay. Like once you have a motion, but before you report the motion, how much delay you want to have. And there's also another, knob. You can use the screwdriver to turn them. Actually, a Phillips screwdriver to make the change. For our purposes, we probably don't need to adjust these. I mean, this is something that if you actually use this in a project, you may want to fine tune this to your liking. So this is for sensitivity adjustment. And there's 3 pins here: ground, output, the signal output, and then you have a power, okay? And there's a couple of pins over here, actually. This is already connected, put it into a mode where it does a single trigger mode instead of a repeatable trigger mode. That single trigger mode means the time trigger is started immediately when it detects a motion. and it will not do a continuous detection. And versus if you adjust the pin in a way that will be repeatable. So right now, what you have here is already in the single trigger mode with this 2 pins actually connected with this little connector put on top of this 2 pins right here. So this is already in this particular mode. So you can change this if you want to, but this is what it's there. So you don't need to change it right now. You can use this as is. Okay. All right. So now, actually, let me show you real quick on the sensor that I have, and then we'll come back to look at the program. So this is the physical circuit. I got this connected. It's very easy to connect. And you'll see on the right-hand side, I have this ground and power connected because these 2 columns are already connected to ground and 5 volts. And the signal wire goes to GPIO 23 or whatever GPIO pin that you need to use, what you want to use. Let me show you this side of it. Actually, let me position this to the angle how I show you in that picture. And the wires, I specifically choose the color. Now, when you're connecting to your physical circuit, you don't need to worry about the colors, but I want to show you the red usually represent. That's how I usually use the color in the freezing diagram. And this red usually represents power, and the black is ground, and then the yellow is a signal wire or other colors. But this is the signal is going to be in the middle. So this is how I got this connected, and I'm going to face this toward the other side because the range of detection is quite wide, and I want to kind of make it a little less. So when I move my hand closer to cause a motion, it will detect actually from pretty far. All right, let's actually take a look at the program before I run this. A sample program is very simple. Again, this you'll see a similarity. I've seen a couple of examples so far with the input devices. And here, we're gonna use the motion sensor class from GPIO 0 and initialize it with the pin 23. Of course, you can use whatever you want. And I also have the LED that's still on the breadboard, and I continue to use that GPIO 18. When there is a motion, when I turn on the LED, when the motion stops, we'll turn it off. So it's that simple. And as usual, this you can pass in your custom function and do whatever you need to do. Okay, this is for demonstration. We're gonna just have the LED light on and up, on or off. All right, so I'm gonna run this, and in fact, I'm gonna kind of put this, take this camera view. I'm just gonna, swim my hand. See, light on, light off. And the LED, very, it's a wide range. I mean, I didn't have to even move my hand really close. Like, like my hand is kind of really far away actually. So motion, light on, and then motion stop, off. So it's a very, very straightforward. Okay, you can stick your hand nearby and then stop moving, and it will stop. It's very. This is the single trigger mode, not the continuous trigger mode. Okay. This is the working of a motion sensor. Pretty straightforward. That's it.